Hello everybody. Today we will discuss the method to determine transfer function of a system from a given state model. We will try to develop a systematic solution. To begin with, we start with the state equation and the output equation as x dot equal to a into x plus b into u, and this is the state equation. We will call this equation 1. We know that the output equation y is c into x plus d into u. This is our output equation. We have developed these in the past. This is equation 2. Now from these two equations, we are expected to find out the transfer function. So we have to recollect what is the transfer function. Transfer function of the system is given by the Laplace transformation of the output, that is y of s, to the Laplace transformation of the input function, that is u of s, with zero initial conditions. This is how we define transfer function. Now, equation 1 and equation 2 are time domain equations. We need to obtain the equations in the Laplacian domain. How do we do? So we try to take the Laplace transformation of these two equations. Okay, taking Laplace transformation of equations 1 and 2. Of course, we need to remember this with 0 initial conditions. We get the two equations to be, we'll go one by one. X dot of s, Laplace transformation of x dot of s is s into x of s minus x of 0 equal to a into x of s plus b into u of s. We have taken the Laplace transformation. We know that the initial conditions are to be assumed 0, so this will go to 0. So now shifting this x of s onto the side, so what we do is we write s into I minus a. This whole thing has to be multiplied with x of s, which is equal to b into u of s. A being a matrix, you cannot subtract a from s. S is a scalar, so you need to multiply it with an identity matrix of the required order depending on the order of A matrix. Alright, so if A is a 3 by 3 matrix, then I should be an identity matrix of 3 by 3. So now from this, what we do is we will try to pre-multiply with Si minus A inverse, both sides. So what do we get? We get x of s on one side, and what we get on the other side is pre-multiplication would mean first this term will come, Si minus A inverse into B into U of s. We will call this equation 3. Now we will try to go to equation 2 and take the Laplace transformation of equation 2 with zero initial conditions. We get y of s equal to c into x of s plus d into u of s. We will substitute from equation 3. Okay, so from equation 3, what do we get? Y of s equal to c into, for x of s we will substitute this, that is si minus a inverse into b into u of s plus d into u of s. Now we will try to take d of s as common factor, so we will be left with si minus a in c into si minus a inverse into b plus d, whole thing has to be multiplied with u of s. So I suppose we are almost there. Y of s to u of s, which is the transfer function. This is equal to c into si minus a inverse multiplied with b matrix has to be added to d matrix to get the overall transfer function. It is a simple derivation of elimination of the unwanted things from the two given equations. That's all. So we have the transfer function before us. This expression is there. Now how to employ this expression to arrive at the transfer function, we will try to see with an example. An example would make us understand as to how to deal with this. So our objective is aim to determine the transfer function, to find the transfer function with the given equations as x1 dot x2 dot vector state derivative of the state vector minus 5 minus 1 3 minus 1 x1 x2 plus 2 and 5 into u and y equal to 1 and 2 x1 x2. So we have these two equations, we are supposed to get the transfer function. Isn't it simple? It's a simple correspondence and computation. We may have to do the operation of matrices, that's all. So how to go about this? The solution is simple. We may have to compare the given equations with x dot equal to ax plus bu. We have this is the state equation. And we have the output equation to be y equal to cx plus du. This is the output equation. So if you compare the two equations to the given two equations with the state equation and the output equation and draw one-to-one correspondence, one can easily write the various matrices ABCD. Matrix A is minus 5, minus 1, 3 and minus 1. This is matrix A. Matrix B obviously is 2 and 5. It's very obvious. Matrix C is 1 and 2 and matrix D 0. Alright, so we have these four matrices. Now we may have to use this expression of transfer function and evaluate. So to begin with, we will try to evaluate step by step. We will first find Si minus A matrix. We will find this matrix. So we need to subtract A matrix from S matrix. Rather, to make S a matrix, you may have to multiply it with an identity matrix, as A is a 2 by 2 matrix. So we try to multiply S with an identity matrix of 2 by 2, S into 1001 minus the A matrix. We will write minus 5, minus 1, 3 and minus 1. What is the computation of this resulting into? This is S plus 5, this is plus 1, this is minus 3, this is S plus 1. We may have to now invert this, Si minus A inverse. So the inverse of this is adjoint by cofactor. You do the operation, so you will get this to be equal to S plus 1. This will change the sign, minus 1, this becomes 3 and this is S plus 5 divided by the determinant of this matrix, that is S plus 5 into S plus 2, rather S plus 1, then plus 3. Okay, That's going to be the inverse. So now if we can split this denominator into all the 4 terms of the numerator matrix, we get this as s plus 1. Simultaneously, this can be expanded. This is s square. This is 6s plus 8. And minus 1 divided by s square plus 6s plus 8. 3 divided by s square plus 6s plus 8. Then s plus 5 divided by s square plus 6s plus 8. So we have done this computation. Now what is the next step? So having done SI minus A inverse, so we may have to pre-multiply this with C. So C into SI minus A inverse. So what is the matrix C? We have identified the matrix C as simply 1 and 2. And this is s plus 1 divided by s square 6s plus 8. This is a boring work of reproducing things, but then we need to do it carefully without making mistakes. At this point, I want to emphasize that you be careful in following my method than my computation. I'm a little prone for errors. Alright, now we will do the multiplication. So it's 1 row and 2 columns and 2 rows and 2 columns. So we may have to do the multiplication. First row and first column, that will be equal to first row s plus 1 divided by s square 6s plus 8 plus 2 3s is 6 divided by s square plus 6s plus 8. First row and first column. First row and second column would be minus 1 divided by s square plus 6s plus 8 plus s plus 5, that is 2 into s plus 5, that will be 2s plus 10 divided by s square plus 6s plus 8. This matrix. It's going to be 1 by 2 matrix. Okay. So this is equal to, we will common the denominator, and this comes out to be s plus 7 divided by s square plus 6s plus 8. And the second term is 2s plus 9. Okay, if we common the denominator and add the similar terms, we get this. Now what do we have to do? Now we may have to multiply this with the matrix B. So whatever we have obtained, now we have to do one computation of C into SI minus A inverse into, we have to multiply it with B, okay, into B. That's equal to s plus 7 divided by s square plus 6s plus 8, 2s plus 9 divided by s square plus 6s plus 8, and the matrix B is 2 and 5. 2 and 5. So this multiplication will yield us as first row and first column, that is 2s plus 14 divided by s square plus 6s plus 8 plus 2 5s are 10s plus 45 divided by s square plus 6s plus 8. This is equal to s square plus 6s plus 8 divided by, you get this as 12s plus 59. This is our C into SI minus A inverse into d. And transfer function is plus d, so d being 0, so transfer function is equal to c into si minus a inverse into b plus d, d being 0, we will get this as 12s plus 59 divided by s square plus 6s plus 8. So this is how we arrive at the transfer function. A very, very simple method. All we have to do is do the computation properly. Carrying out the computation properly will give us the exact result. Right? A quick recap we can have before we wind up. So our objective is to find the transfer function from the state model. This is being given. What do we mean by state model? State model is represented with the help of two equations we are already familiar with. We have done several problems. So one is the state equation, another is the output equation. However, we know the transfer function is the Laplace transformation of the output function y of s to the Laplace transformation of the input function u of s with zero initial conditions. So we have an equation for x dot and we have an equation for y, which are time domain equations. So all we have to do is to take the Laplace transformation of these two equations with zero initial conditions. We were able to get an equation of this nature, wherein we simply manipulated and we wrote what is x of s equal to. Okay, x of s we were able to get it as si minus a inverse b into u of s. Now all we are interested is in y into u. So try to take the second equation, then substitute for x, that's what we do, substitute for x, and we were able to get on the right hand side things in u, take u as common factor, then y to u ratio is available to us. It is simple. Transfer function is this, c into si minus a inverse into b plus d. We may have to remember this expression to compute the problems. So we took the problem to find out the transfer function of a given system, which is we have the state equation, we have the output equation. What we did, we simply did one-to-one correspondence, identified what is a, this is b, and obviously this is my c, and there is no d. So we were able to pick a, b, c, d from the given equations. So we step by step computed. We first initially did si minus a, then we did si minus a inverse multiplied with c into si minus a inverse, then we finally did c into si minus a inverse into b, and as there is no d, we kept the transfer function as it is. So we were able to get. So one may have to be very careful in computing, otherwise it doesn't require any great concept. You may have to just do matrix manipulation. I hope this is clear. Thank you very much.